Okay, your attendance code will come up on the screen. Please take your attendance first. For those of y'all who've been attending my classes regularly, you'll realize that I do not want the last 3 seats to be taken up. So if you can all come down. So the 4 girls there, the boy there. If you're in my class, you're in my class. If you're not, you're out, please. Thank you very much. 3 rows, sweetheart, down. All 3, all down, come. Right in front. Come, you're supposed to sit in front. Not sitting together. Thank you very much. The front seats are vacant. You promised. Okay, we're going to get into something that is the core of the module, which is your diagram. So today we're going to try to explore, let's see how it goes with time, and we're going to explore the understanding of the base diagram, which is use case diagrams. So once we do that, during the tutorial sessions, I will take you through a few websites for you to be able to familiarize yourself with these diagrams, right? And based on the understanding that you have from today's class, you know, you should be able to start drawing your use case based on the practical work and also your assignments. So you got to get that going, and then, you know, hopefully you'll be able to take through the understanding of use case from this class to all your modules whenever they will require you to draw use case diagrams. So the best playground for you to have this understanding would be here in this class. So what I'm going to do is I'm going to load up a few sites that I'm going to help you have a good grasp of use case diagrams. So just give me a moment and then we will get there. So Creately, Visual Paradigm, IBM are 3 of the good sites if you want to do your own, you know, understanding of UML diagramming. This would be the best websites that I can go to. But prior to this, let's go through the slides and we'll run through a basic understanding of it first, okay? Right? So, let's run through and we should be able to get there fast. Okay, what we're going to try to understand in this session would be, we're trying to, let me just run through for you a bit, then at least I can see, okay? Can you all see that there? Okay, right. So we are going to go into what we call the component-based development. So when we talk about component-based development, we have been doing a lot of analysis and the scenario that you've been given in your tutorial practice sessions are very initial phase, which is requirements determination and trying to find a way to gather your requirements from your potential stakeholders. So we've been running through a bit of analysis, but what we're going to go into today is we're going to go into architectural design, and that is going to take some understanding in components and engineering. So we are going to expose ourselves to diagramming techniques, which is what we are focusing on in this module would be object-oriented software development tools, right? So the tool that we are going to be exposed to in this module is called the Unified Modeling Language Design Tools. And in this design tool, which is object-oriented based, we're going to start to explore things such as use case diagrams, class diagrams, object diagrams, and many more different diagrams that we're going to practice, right? So these UML diagrams are based on what we call the rational unified process. The unified process tool starts with what we call inception. Now this is the object-oriented platform. The example that I gave you that we are trying to understand the basis of software engineering revolves around traditional method. The traditional method, the most obvious methodology is the waterfall modeling technique. The waterfall modeling technique takes through sequence of activities starting from preliminary investigation down to maintenance and support. So you realize your practical exercises, the 2 question was taking you through that particular strategy, right? You understood what do you do into implementing applications. Now we are going to another methodology understanding, which we're trying to explore the object-oriented. We've passed traditional, we're going to go into object-oriented. So in object-oriented, we deal with things such as classes, components, objects, right, database tables and stuff like that. So to go further onto this, we will explore what we call the unified process tool. Now the unified process tool that is based on the rational modeling technique goes on the basis of inception, elaboration, construction, which is basically your development, right? So in the elaboration part is more of what we do is the UML diagramming. So we are trying to extensively explain the boundary of the system. So the best way to understand the boundary on a high level inception is the interaction of the necessary stakeholders with the system. So the system has got a boundary, and outside the boundary would be the direct stakeholders and the indirect stakeholders, right? And what happens within the boundary would be what we call the system scope, all right? And that scope in the UML modeling technique will be identified using this term called use cases. All right, so the top level view of any system is depicted in a use case diagram. A use case diagram is the start, right, of the elaboration technique to understand what we call the scope of any system. Okay, so the best way to understand use case, if you were to take the traditional understanding or even generalistic computing principle, is to comprehend what is a process. So in any given application, or we tend to use the word system, in any given system or application, right, they are what we call processes. Now, processes enable us to define who is doing what, when to do it, and how to reach a certain goal. So processes basically, under the fundamentals of software engineering, right, you have got problem, directive, opportunity, which falls under what we call new or change requirements. When we take it through the engineering principles, we have got new or change system. So requirements are all very loose, all right? A passenger might have a requirement as different to a cabin crew or a person handling the cargo, right? So when you consolidate that and look at commonality of processes, this is what we call creating the boundary, and that indirectly changes the scope of any system. All right? So like I said, we are exploring unified process. So unified process is what we call a modern process model framework. Now, the process model framework derived from the work on the UML and associated process. So under the unified process, they have introduced the unified modeling language. What does the unified modeling language do? It is firstly a framework. That framework enables you to have a clear understanding of all processes that designate itself within the boundary of the system. Okay, right? So it is the leading object-oriented methodology for the development of large-scale softwares, and it maps out when and how to use the various UML techniques. So within the UML diagramming, you have the start diagram, which is the base diagram of all, which is use cases. And then you can even go down to what we call sequence diagramming, or even activity diagramming, or collaboration diagramming, that goes into the nitty-gritty of how objects or tables, right, or any component or element within the boundary of the system interacts. Understand, right? So we are going and studying the unified modeling that falls under what we call the rational unified process, which is a methodology, right? And the rational unified process, you must understand that it is part of managing object-oriented software development. And all of it starts with iterative requirements management. It's an iterative and its requirements, obviously, because like traditional, you have to obtain user requirements. And what we are doing today is we are going to explore their component-based architectural vision. The first diagram, I showed you architect design and component-based. So under the component-based and architectural view design, we use visual modeling, which is the UML. So visual modeling of systems, right, to be deployed using UML diagramming technique. Okay, and that's the start, okay? So I'm going to go on a little bit more. So we're going to explore the modeling technique, right? And we're going to start with trying to understand all the different principal UML models. Again, UML falls under the rational unified process. What is RUP? RUP is an object-oriented software development methodology. Now it starts with the iterative inception, and then it goes into closing the system on delivery, and it goes into keyword iterative. So the various types of models or diagrams that you are going to expose yourself in this module are all the list that you see here. So today we're going to briefly talk about use cases and class diagrams. The next few weeks we're going to look into sequence, collaboration, state, activity, component, and also deployment diagrams. All right, okay, so this is the core of the module. This will stay with you throughout until you graduate. And even today, I have got students who are all in the software development line. Even as a data analyst or a data analytic consultant, they are creating use cases. So where is your start to understanding use cases? It's this class. That's why this is a core module, right? That's introduced in the first level. And this is the breadth and depth of getting the system scope right. So if you remember when we looked at traditional method, we had design, right? This is logical design. This is not physical design. Physical design would be the screen interface. The logical design would be the intricacy of the process, operation, functions, features, right? Every single interactivity, top-level view from stakeholders with the system, as well as all the interrelationship between operations, objects, classes, whatever, or tables. All right? So we're going to firstly try to understand the primary. You can't start a UML understanding without creating the first mother of all diagrams in UML, which is the use case diagram. Okay? So the use case is basically a top-level view showing you how the system interacts with its user. So drawing the use case is very important. Drawing the use case right is a skill that you are going to learn in the consecutive practical class, right, that you're going to take on this week, okay? And then we proceed with all the other diagrams. As and when we enter each one of these diagrams, you will see the differentiating flow, right, of interaction that takes place within a system. But to understand the scope and the boundary, the use case comes in. So let's explore a little bit more about use case, right? So these are all the modeling diagrams that you're going to be acquainted with, right? So UML in a sentence is a graphical language for visualizing, specifying, constructing, and documenting artifacts of a software-intensive system. What is artifact? A lot of students, when I teach them in the final year, when I keep on telling them that your capstone project has to produce an artifact. And then they raise their eyebrows. What is artifact, you know? Artifact is a fully functioning application. That's an artifact. So your problem, study, and your chosen solution has to depict itself as an artifact. An artifact is a working system that you can use to transform raw data to produce it as a fully functioning application, generating necessary information to the relevant stakeholders, front end or back end. So artifact is a fully functioning application system. Do you understand that? That's a very important terminology you need to ingrain into your head, because at the end of the day, your last straw of a final year degree student would be to complete a capstone project that takes through 2 capstones. Capstone 1, which is what you're learning in this diagram, depicting the requirements into a diagramming technique, and then taking the transition to creating an artifact, a fully functioning application. Everybody's clear? Right? Great. Okay? Now, so we are going to go into visualizing. So we're going to, so these are some of the, the diagramming, right? How it looks like, okay? So we're going to be acquainted with all these structural modeling step by step. I don't want to go into a lot of it today, right? I just want to show you how a use case looks like. Generally, when you start researching online, you will realize that you will see a lot of common use case diagrams, but I will tell you what is good practice, right? You do a search, give me an example of a library management use case diagram. You will get all sorts of diagrams, but I am going to teach you this whole week in a practical session, which you should not miss, is what's the right way to draw. So, for example, this is one way of drawing it. I will tell you which way is the way that we're going to use. Okay, so this is one way of, so if you look at a use case modeling sample UML diagram, you can see that this is a system of goods selling via catalog. So you have got the back end. You see, like this diagram, listen to me very carefully. This diagram has the back end stakeholders on the left hand side. So you have a seller, and then you have a generalization of a type of seller called a seller of a computer, right? So that's the generalization. So they have the provider who's the seller at the back end. And then they have the front end who's the customer, and the type of customer using, if you can, all of you all can pay attention to this small little arrow, It's an arrow with a clear head, all right, that generalizes in terms of customer of computer inheriting the base class of a customer. So the type of a customer is a customer who is purchasing computer, all right? So rightfully, this would be front end and this would be back end. So you will see some use case diagram where the front end stakeholders will be on the left, all right? So usually diagramming, we start from the left to the right. So it initiates from the left to the right. So this example that you see, so presumes that the seller is the front end. But in a perspective of an analyst or a developer, you always think of the system that you build it for who? You build it for the customer. So the more professional, cleaner way of drawing use case diagram is to always put the customer front end on the left hand side. But this is an example. Everybody clear? All right. So you see that use case, the most important thing is to draw a boundary. Do you see this line here? It's a boundary. This is called a boundary. So this is like the innards of the system. So it's called a boundary, or it's also called a scope. All right? So within a scope, what are the various happenings? Or in traditional way, we like to call, what are the main activity or processes inside a system selling goods via catalog? So if I didn't show you this diagram, I'll tell you, brainstorm with the person next to you, what could be use cases, right, of a potential system that sells good via a catalog. So you'd have to brainstorm. Of course, in reality, you will speak to a potential client providing these services. Then he can tell you, okay, these are things that we do, right? And you'll be able to. But then if I tell you off the cuff, common system, okay, draw me a use case of a library management system, or airline reservation, the common systems, right? Or movie ticketing system, right? So then you will see a lot of y'all will have common, but a lot of y'all will probably think of other intricate kind of processes that happen. So in this use case diagram, please paying attention because I can see some of y'all on your phone. I don't think I'm on live on the phone, right? Okay, so listen very carefully. I know who you are. Now, so a seller, right, can also make an order, and a customer also can make an order, right? And these use cases, the add-ons to these use cases are two features called include and extend. One is a must, the other one is an option. We're going to explore this include and extend dotted lines a little bit later, okay? So under the make an order, right, you might have provide customer with information, agree with payments, right? You can have order goods from inventory, right? So only then you will be able to make an order. But there will be a potential that make order, right? You can have, order goods on catalog. There will be a potential, right? And then you can have a make order of computer where you already have a decision that you have to make. You already want to make an order of a specific type of product. So this is an example, right? But what from the example I want you to see is the stickman that's used to identify the user, the boundary of the system that's closed up by a... So in the exam, when students don't draw this boundary, you don't get 2 marks. 2 marks is for that boundary. You don't draw the boundary, you lose 2 marks. You don't draw the users as a stickman, you lose 2 marks. So we call it notations. So notations, drawing, using the right. If some of y'all draw a circle instead of an oval, minus 1 mark. So do you see this is not a circle, huh? This is an oval. So diagramming, notations are very important. So start your first practice using the right notations. And with Draw.io or Visual Paradigm, the diagramming tool, automatically they will have either use case or they'll have their diagrams there. The stickman will also be there. So you can just adopt it. It's just you dragging and dropping. They give you all the notation, you drag and drop the correct one, and you name it according to what you think is the right use case. And there are a lot of other stuff that, so that's use case. Something that's a bit different from use case. See, use case is a little bit, I'd like to show you this diagram first before we go on further, so that you have a better understanding to differentiate. If you look at this diagram, under the UML diagram types, the best way to understand UML diagram is to see the differentiation of the types of diagram. One shows the behavior. I always like this diagram to be on the left, because you have to draw the behavior, which is the use case diagram first. Only then from the use case diagram, you can start to draw the structural view. Only when you know the top level view, only then you'll be able to draw the other diagrams. If you don't know what's the boundary of the system, you cannot go to the other diagrams. So rightfully, if I were to be the creator of this website, I will put behavior on the left-hand side first. Behavior, left-hand side, first diagram, highlight use case in red. Without the use case, you won't know the boundary of the system, and that's not going to be very, very smart of you as a designer. All right? So this is a good, you don't have to take a photo of it. I've shared with you these websites in your practical session. It's there as a link. So we are going to explore first use case, then we are going to go into one behavioral diagram and one structural diagram. The difference between these diagrams is the use case diagram again is a view of the system and the interactivity between the key players of the system with all the operational flow that is called use cases within the system. So it's a super level view of the boundary. Whereas when we go into the next diagram, which is a class diagram, it's a little bit more of a structure view, because from the use case, you identify which particular class or object or database table, right, or components that you would want to show the intricacy of the movement of these elements between them. So that is what we call structural, and this is what we call behavior of the system. So this is a very good diagram. Now pumping back up to this. So this is how a class diagram will look like. So in a class diagram, what we have is three components. We have what we call the name of the class, and then you have got what we call attributes, and then you have got another, so three compartments: name of class, attribute, and the operation that is conducted, right, within that particular class using relevant attributes that's part of the class. So again, the class diagrams are divided into three: the name, the attribute, that means for a person, the attribute that holds your record will be your last name, first name, address, phone, birth date, age, right? And then you probably have a generalization of a type of person that you will inherit the general attributes. You don't have to call these attributes back again, because patient is a type of person, right, in a hospital. And something that's unique in terms of the patient in the attribute, that's an add-on to the generalization of a person, would be amount and insurance carrier. And the operations, whether private or public, will be operations that is either make an appointment, the patient will either make an appointment, or calculate last visit, change status, provide medical history, everything that takes data, processes it, and transforms and leads it to a different object, instance, or component. This is visually how a class diagram. Now, From today's class onwards, you will have to start picking it up. You will have to go and research on class diagram. I've shared with you 3 sites. In your practical work, you have to go and do your own reading up. And then you have to come in, you have to start to draw them. Right? I will not be sitting next to you and say, okay, let's draw the box. Let's divide it into 3. Let's brainstorm together. That is between you and your friend next to you in your practical class. This is what we call independent learning. Okay? Now, so that's another sample. You can explore that. I want to go more onto use case. All right? Because this is the most important diagram. And this one without fail in the exam. In the exam, I might not ask you class diagram. I might ask you sequence diagram. But in any PSE module, use case is a must. You cannot run away from use case. So this is the part where you can score. If you really understand use case, and actually telling you under the behavioral structural diagrams, they are the most easiest diagram to understand. All right? So, use case captures some user visible function, large or small, depends on the level, right? And this is like a very simple format, right? You have on the left, I don't expect you to see the words, but what I expect you to see is a stickman, arrow that connects here. If you have a line, sorry, not the arrow, if you have a line that doesn't touch the oval, -1 mark. So drawing technique, clean drawing. In the exam, you have to use your pencil. My advice in the exam, drawing any diagram, use the pencil. The words inside the oval, you can use a pen. Move from the left to the right. In use case, front end user on the left, back end user on the right. What do you see here? The square. Why do you draw the square? The boundary. Simple rules I'm giving you. A stickman has got a head. He's got 2 hands, 3 hands, right? And he's got 2 legs. His leg is not straight. His leg is. You draw straight, -1 mark. I'm kidding. Okay, all right. Now, so let's look at use case. Many system development failures can be attributed to not involving the client. You don't identify all the right front end, back end, your use case is a fail. Okay? Now, the use of use cases is designed to focus on our attention back on the users, right? So the users are getting out of the system. That means what am I using the system for? Right? To use the system, what do I have to give? After I give everything, what comes back to me? So indirectly, I provide something to get something back. But when I provide, everything that I provide goes through a lot of changes because data gets manipulated. So data gets manipulated, it gets merged, it gets transformed, right? Transformed data becomes data back again, but in the form of valuable information to a certain level, but that becomes data back again and goes processed. So data goes through many transitions because it goes through a series of many different operations. At the end of the day, I give you something. If I'm a user of the system, give me back. But there are also indirect users, people who don't use the system directly but wait for information that is provided to the system. But I might not access the system. Somebody, another use case might just give it to me. Am I drawn in the use case? No, I am not drawn in the use case because I don't interact with the system. Understand? Okay? Right. Moving on. So you can read, right? You can read. I'm going to go into the diagrams. Okay? So there's scenarios, right? Okay, so there's text format. Now, how to use case. Hang on, let's move a little bit more. You can read. Okay, now, so beautifully big and clean here. In this example, we assume customers can make bookings via the web. Thus, they become direct users. So a customer, direct user. The actors must interact with the system in some way, generally directly. So the use cases, someone who rings a company to the user of the system, what system are we modeling? You need to determine the scope. So a customer, the common thing that he will interact with the system is he will pay for booking. JC, you're doing it again. He'll pay for booking, right? And he will make booking. Right? This is let's forget about what the system is all about. But I'm showing you a person that's interacting with the system. And then this is actually not the boundary. You see, the boundary cannot have the customer inside it. The boundary is the customer is outside. Right? The boundary has to be all the ovals inside. This is just showing you as an example, okay, of what we... And the most important thing for use cases is active verb noun. If you fail English, I cannot help you here. I'm not teaching English. You should know what's active verb noun. That means it's actually happening. It's not past tense. Okay? So, you will see that use cases in the context of the system or part of it, this is a correct way of drawing. Why? Your boundary, it's a car hiring system. Your actors are all on the left. Okay, but what do you see here that can be changed and made it cleaner? Anyone? What do you see that's a small little cleanup that you can do? If everybody listens to me in the class here today, you will not make the mistake in your practical. I highly doubt everybody's going to listen, but let's try. What do you see based on what I said earlier about front end and back end users? What did I say that is not in this diagram? Everybody is still in the weekend, is it? It should be on different sides. Yes, everybody give him a round of applause, please. Very good. So, customer front end on the left. Who should be on the right? Hey, hello, pretty obvious, right? Who's on the right hand side? Staff and receptionist. Front end. So you just move these fellas and his line. So the customer, car hire system, the customer pays for booking or make booking. Or you want to say, miss, where's the login? Add another use case. He has to log in first to access the system, am I right? Okay, so draw another line up there. Draw another oval. Within the square, log in. Understand? Right? So this is, so you will see something that is a bit more unique because the customer makes booking, right? Then you see, hey, the receptionist is also making booking. Yeah. You have a potential that a customer is calling in and the receptionist is making the booking customer. Or directly, there will be a customer that will access the web and can make booking also on his own. So the option for you to reach, you can take via phone call, right? Or you can have somebody come in front of your counter, the receptionist will access the system, or you have the customer who can use a kiosk and he can log into the system. Are we all clear? So you have to think creatively here. So if I would tell you, go and create a car hiring system, miss, how does it work? That's the part you brainstorm. La. And everybody's car hiring system boundary will be different. La. But nobody can run away from login. You got to make a booking. Correct or not? The common operations, you cannot go wrong. Right? So imagine if every university needs an attendance system. So you know that there are some common operations, right? The student will have to take a code or something like that and make sure that the attendance is taken. But the way you name the process and perhaps the flow for verification might be a little bit more different. Okay? So moving on, right? So then you have got some behaviors common across use cases. We can place this into use case of their own and connect them via an include association. Let me just give you a very simple brief out between include and extend. First, do you see that the arrows are dotted? Understand? Not the main arrows as you see here. So what's the difference between include and extend? Behavior, we got it because it's use case. The include use case is never called on its own because you are depending on the base class. So include will depend on the base class. So in order for you to, so I always like to get the students to look at include as a subset of the base class. That is a very easy way to understand it. You have to have the include for the main superclass, right? But for extend is an option, right? So here you have got, in order for you to draw the cash and check balance, you have got a specific requirement to first ask which account. So you have to specify. So you have got the superclass, and depends on your arrow, you have got your base classes. So a customer will want to withdraw a cash and check balance, but then both these sub use cases depends on a main class to specify account first. Only then, whether or not that account has a right to withdraw cash and check balance. Okay, right? Again, the 3 websites I gave you in your practical class, amazing explanation of include and extend, which you have to read. Okay? In extend, many use cases will have certain, but with any variation. Now, the extend association allows a basic use case to incorporate additional under certain. So, the keyword to extend would be optional part of use case. Right? Okay? So, for example, if you want to withdraw money, right, from the account, there's an option of you want to specify the denomination of the currency. It's an option. All right? So, wherever there is a situation that there is an option that might be activated, the user has an option to use that particular use case process, then you extend. It doesn't get activated all the time, only depending on scenarios, okay, and given instances of the operation, right? So in this case, complex or alternative costs, adding new use case into existing use case where you have got more options, but it might be a nullified also, okay? So for example, a withdrawal may normally result in the ATM deciding what notes we get. We may specify an extension which allows the user to vary the behavior by letting them specify the denomination. So you have got withdraw, but then you know you have got a withdraw cash can have an option where you can specify denomination. All right? But then in order for me to withdraw cash and check my balance, I have a base class that first it will have to specify the account. So a must versus an option. If everybody follows this, you will know how to use include and extend. And your diagrams will have a lot of include and extends. All right? So please do your own recap also, okay? Then you have got generalization. Generalization is if you were to look at the arrow here, okay? We can identify use cases that accomplish the same goal but in different ways. We can note that similarity by using generalization. Both fingerprint scan and insert card are kinds of identify user and account. So under your validation, it will carry perhaps some same attributes that validating can have an option of either a fingerprint scan or an insert card scan. But it falls under a parent class, we call it, if you were to draw it in a class diagram. Okay, but in this case, for use case, we use this same generalization arrow with a clear head in order for me to look at 2 options. But there are 2 forms of validating, right? What's the time?
10:54.
So I would advise you to go through all of this. There are many more examples. As you know, we have another class that will come in and hound us now. So when we get into the practical session later, I'm seeing the first group, 1 to 3 o'clock. Get your practical one going. But before that, I will advise you all to run through the balance of this slide to look at use case and class diagrams. I will probably run a little bit of short lecture on class diagram later on when I see you all for practical. And on Wednesday and also on Friday. So for the Wednesday tutorial slot, please have your, have your practical done. And then we can present. So each group, just like how we did last week, everybody has to be ready. Improve your presentation skills. Show me your sample answer for both the practical work. For this group, if you were a bit ahead of me, you would have done the use case. Let's see what you have. If you've studied it up a little bit. But if not, we will do it together. For Friday, you have ample time. The practical that I have on Friday, 10 to 12, you have ample time to give me a well-curated use case. Read up on your class and understand, include and extend carefully. That's the objective of today. Not that I'm not going to visit class next week. I'll still visit class, but we'll have to go to the next few diagrams also. So remember, I have only 1 hour of lecture. I can only do a little bit. And the rest is a lot of your hands-on during the practical sessions. And my advice, when you start to draw your UML diagrams, work with your teams. If you're lost, the first person to look at is your team member. This is what we call teamwork, right? Unless everybody fails, then the big gun comes in to help. Okay? So this is what we call peer support. How many of y'all still do not have, I think this is the last. This is tough because I still have people coming into classes and assignment has started. So how many of y'all do not have groups? I still have the scenario here. I have to write to the academic team because it's a bit tough. May I know why y'all are coming very late now? What happened? Okay, all right. Which tutorial are you in, may I ask? Monday, Wednesday, or Friday? Oh, Friday's group is too big already. Friday, we have 6 in a group. How many of y'all do not have groups for assignment? One more there. You, my dear, you're new? Are you new? Are you new in the class? Do you have an assignment group? No, my question is, do you have a group for your assignment? She says yes. Communication breakdown. Okay. Can those who do not have groups meet me outside, please? The rest of y'all, thank you very much for your time. I will see you all in your respective practical sessions. Bye-bye. Thank you very much, guys.